Hey, hi everyone. Welcome to another video. And today we are going to start a new series which is called as Innovation, Technology, and Product Management. So, this series we will talk about innovation specifically, and we will discuss about technological innovation. Okay, and primarily, but we will discuss all the innovation frameworks that are there, and we will go into specific examples, case studies, and frameworks in deep as a part of this series. And we will also go into deeper into product management. Okay, so that's uh, and also maybe business process analysis and business analysis. So that also we will cover as a part of this series only. So today is the first video of this particular series, which is innovation, product management, and technology. Okay, so first thing that we are going to discuss is TRIZ. Okay, so TRIZ is an innovation framework, and yeah, so I've asked AI to provide. I've given it a prompt basically, and that prompt is, can you provide me details about TRIZ innovation framework and all 50 principles that are used in TRIZ innovation framework. I want to summarize details of this TRIZ principles, 40 principles, along with real life examples from India, US, and UK. And how this TRIZ can be applied to product and technological innovation. I asked about QFT also. We'll go through QFT later. Okay, so today's topic is only TRIZ. Okay, so let's see what's this TRIZ, and then we will see what are the 40 principles. Summarized details we will see for today. We will go into each principle in detail in the coming videos. But today's summary, okay, what this framework is, what is the summary of the 40 principles, and some examples we will go through. Okay, so that's the topic for today. Okay. So TRIZ is an acronym, and it stands for a theory of inventive problem solving. Okay, it's a systemic innovation methodology, and developed by Genrich Altshuler and from USSR. This is Soviet Russia. Okay, states of Soviet Russia, which was there before Russia, and the TRIZ framework came from USSR, and TRIZ stands for Theory of Inventive Problem Solving. It's developed in 1940s to 70s. Okay, what this TRIZ does basically is, instead of doing brainstorming, which is a random process, brainstorming, you get ideas from different people, and you jot down all those ideas, and you weigh those ideas against. We'll go through brainstorming also. That's a methodology. We'll go through that. But yeah, instead of doing brainstorming, which is coming up with ideas, weighing those ideas against certain factors, and the pros and cons of those solutions or ideas, to solve a problem or to come up with a product. What TRIZ does is it analyzes patterns, okay, in patents and inventions. So already whichever products or new inventions or patents that have come, new patents, so TRIZ analyzes the patterns in those patents and inventions to extract the repeatable strategies. So it analyzes these patents and inventions and extracts a repeatable strategies to solve contradictions and create breakthrough solutions. Okay, so this framework could be used to create a breakthrough product solutions and to solve contradictions also. Okay, so that's this TRIZ. And key TRIZ concepts are contradiction focused. So most inventive steps resolve contradictions. So you want something to be stronger and lighter at the same time. Okay, so that's a contradiction. Want something which is stronger generally is not lighter. Okay, it is heavier, but you want that. That is a contradiction focused innovation. Okay, and when you solve that contradiction, you will come up with something new, a product or a breakthrough solution. Second thing is ideal final result. IFR is a key concept of TRIZ. This aims for the ideal system that performs the function with minimum cost, complexity, and harm. Well, it's like a ideal solution that comes with the function with minimum cost, complexity, and harm. Ideal final result. Okay. Resources, the other key TRIZ concept is resources. Use all available resources, which includes material, energy, information, time, space, and functions. Okay. And 40 principles are there. The inventor basically analyzed all those patents and inventions and came up with these 40 principles, which are called as patents of invention. And this is the toolbox, okay, which you can use to come up with new products. Other tools are also there, like arrays, which is an algorithm for inventive problems. Substance field analysis is there. Nine windows is there. S curves are there. Trends of evolution are there. We will discuss about these 40 principles for today. Okay. And where does this TRIZ actually, in terms of use case, fit is product development. It can be used for technical problem solving. It can be used for patentable improvements. It could be used for design for manufacturability. It can be used for, and cross domain inspiration. It can be used for TRIZ framework. Okay. So, what are the 40 TRIZ inventive principles? Okay, and summary we will go through today with some real life examples to understand what that principle basically means. We'll only focus on examples from US, UK, and India only. Okay. Um, yeah. So first principle is segmentation. So segmentation is the principle where it talks about dividing an object into independent parts. Okay. So that is what segmentation is. Okay, so that's the principle that you do the segmentation, divide an object into independent parts. An example of this is products that came up using this principle are modular smartphones. Motor mods can detach attach modules for added features. So this is divide object into independent parts. That's the first principle of TRIZ framework, segmentation. Second thing is taking out or extraction, removing a disturbing part or property. Okay, example is cardless bank branches. So what it removes, which is a disturbing part or a property, is removing paper forms. It removes paper forms, and it uses kiosks or mobile onboarding to remove these paper forms. So remove or taking out the disturbing part or or property. So that is taking out or extraction is the second principle. Third one is local quality. So make each part do the most appropriate job. What local quality means. Example is multi-layer water filters in India. They are separate cores, fine and activated carbon stages are there, localized by function. Okay, so we will go through each one in detail. This is just a summary video where we are going through all the 40 at once. That's too much, okay, for a single day. We will go through each one in a single day, okay, and very broad, very wide variety of examples we'll go through. But for today, just this is a basic video of what it is and some basic examples to make you understand the concept. Okay, so local quality we have covered. Asymmetry, so change shape or symmetry to improve performance. So example is the computer mice. You can change it, make it asymmetrical to fit the right and the left hands. Okay, so ergonomic asymmetrical computer mice is an example of asymmetry principle application in the real world. Merging or combing, so combining similar functions or objects. So example here is integrated smart thermostat plus voice assistant units. Merging, another example is iPhone is also a merging example, right? So what basically Steve Jobs did is he merged multiple things. He merged a music player, a phone, and a computer into one particular device, and that became an iPhone. Okay, so that's what a merging concept is. Okay, where you combine multiple objects or multiple functions into one thing. A multi printer, which does like multi device, like it does Xerox, it does for suppose printing. That is a multi device. Okay, so that's what merging is. Merging multiple objects or functions, which is very useful concept. Okay, and a principle also. Okay, so that's a fifth concept or principle. Sixth one is universality. So make a part perform multiple functions so that other parts can be removed. So there we are putting multiple objects into one in merging. Here you are making one object do multiple things. Universality. Okay, Example is multi-purpose chula or a stove design in India, which can be used for cooking and water heating in rural solutions. There could be other examples, but this is the example it has given for now. But understand the concept, universality, where you make a particular thing do multiple functions, okay, so that other parts can be removed. Okay, nesting, matroshka, that's a, I think, Russian word. Place one object inside another. Okay, so this example is collapsible travel cups that nest for storage. Silicone collapsible cups, that's an example of nesting. Okay, counterbalance, anti-weight, so compensate for weight or harmful effect. So yeah, counterbalance, counterweights are used in rail balancing systems or camera gimbals to stabilize movement. Okay. Then we have prior counteraction or preliminary anti-action. Take action beforehand to prevent a harmful effect. Example is pre-treatment of wastewater before entering main treatment plants to avoid clogging. The 10th principle we have is preliminary action or pre-processing. Perform part or all of the action in advance. Um, Pre-charged battery packs shipped to reduce initial setup time in field devices. So that's an example of preliminary action. Cushion in advance or buffering is the 11th principle. It introduces buffers to absorb harmful effects. Airbags or crumple zones in cars or engineered buffers. Okay. Airbags protect you against accidents so that you don't get harmed. So that's cushion in advance or buffering principal application. Equipotentiality, make conditions equal to avoid penalty from movement or processing. So example is flat panel solar arrays with micro inverters to optimize each panel, equalizing outputs. That's the equipotential. To make conditions equal to avoid penalty from movement or processing. Okay. The other way around, inversion, so reverse action or orientation. So you're just turning around the things. A swappable camera modules that flip orientation, selfie versus main camera is an application of it, or reverse workflow. User uploads to cloud and device is minimal. So instead of doing things in a certain way, you just reverse that way of doing things. That's what the other way around means. Spheroidality or curvature, use that curvatures, curved surfaces or movement like rolling. So ball bearing mechanisms or spherical drones for omnidirectional movement in indoor robotics. So that is what curvature is. uh, yeah, so that's what spheroidality or curvature is. Used curved surfaces of movement like rolling. Nowadays there are some cars which are being invented where you can do parallel parking, and the wheels are uh, so it's different wheels compared to the normal wheels in cars. So that is an application of this spheroidality or curvature. Dynamicity or dynamics, make elements adjustable, moving or flexible. Example is foldable phones, adjustable stroller handles to fit multiple users. So that's the dynamics. Make adjust elements adjustable, moving or flexible. This is also a very key concept, dynamicity. Having elements adjustable or moving or flexible. This also gives rise to multiple new products. Partial or excessive action, do more or less than required temporarily. Okay. Overclocking CPU briefly for heavy tasks, then throttling back. You're using particular thing more or less partially, and from that also new devices or new products will come into picture. Another dimension, so move into 3D or change spatial orientation. Instead of doing horizontal forming, do vertical forming. Use vertical dimension to increase yield per area. Instead of building skyscrapers, this is another dimension. Okay. Moving things vertically instead of horizontally, having a villa. So that's another dimension example. Mechanical vibration, use oscillations or quick actions to improve process. So ultrasonic cleaners for jewelry and medical instruments in small labs. That's an example of mechanical vibration principle in action. Periodic action, intermittent instead of continuous action. So pulsed irrigation or pulsed power to pumps to save energy while maintaining performance. So this periodic action is used in saving energy, where you give pulsed irrigation or pulsed power to pumps. Continuity to useful action and ensure continuous operations of useful functions. UPS system is an example of this that maintains continuous power to servers during mains switchover. Skipping stages, this is another principle. Conduct processes and leaps, skip unneeded stages. Example is mobile first by banking, which bypasses the onboarding steps. So this is the skipping stages application. Convert harm into benefit, use a harmful factor for advantage. Example is from USA, energy harvesting from braking, regenerative braking in hybrid and electric cars. Yeah, that's what they are doing. Energy harvesting is an example of converting harm into benefit. Feedback is another principle. Introduce feedback loop. This is a long video. We will go through each one in detail. Okay, so don't get overbogged with information. This is just to give an overview that this thing exists and these are all the things that are part of this. Okay, introduce feedback loops, smart thermostats using ambient data to adjust heating patterns. So that's a part of feedback, introducing feedback loops. Feedback loop is again in Ola, Uber, you have this recommendation systems, right? Where not recommendation systems, rating systems, that's also a feedback example. Okay, intermediary, use an intermediary carrier or agent to transfer or change payment wallets that act as intermediaries between bank and a merchant. So using an intermediary carrier or agent for transfer or change, that also gives rise to new products and innovations. Self-service, self-repair makes systems serve itself or perform maintenance. Self-healing software systems that roll back faulty updates automatically. So that's an example of it. Copying approximation, use a simple cheap copy instead of the real object. Use example is 3D printed prototypes for validation. Rapid prototyping you use to create 3D print prototypes for validation before full production tooling. Disposable or wireframes also, that is three prototypes you use. uh, Disposable, cheap disposable elements make parts cheap and replaceable. Single-use sterile engines, syringes in public health in India to prevent infection. So this is an example of invention that came from this disposable or cheap disposable elements principle. Replacement of mechanical system, replace mechanical means with sensory, electronic and optical means. So electronic shutter cameras replacing mechanical shutters in DSLRs and phones with electronic shutters. Okay. Or, yeah. Pneumatics or hydraulics, fluid base, use fluid or gas to transfer or modify force. Hydraulic damping in modern suspension systems. So that's an example of it. Flexible shells and thin films, use membranes, films and coatings. So flexible packaging films with the barrier coatings for food preservation, using flexible shells and thin films. Okay. Porous materials. So use materials with controlled porosity. So catalytic converters using porous substances for exhaust treatment is an example of it. Color changes. Use color or optical changes to indicate state or function. So temperature sensitive paint on pipelines indicating overheating. So that's a real world application of this color changes principle. Homogeneity, making interactive interacting objects of the same material or characteristic, using same metal alloys for mating parts to reduce galvanic corrosion is an example of it. Discard and recover, reject and recover, this is the 34th principle. Make parts separable to recover or discard. Example is easily removable battery modules for recycling programs. So that's a real world application of this principle. Parameter changes, change measurable parameters like temperature, pressure, concentration. So heat pumps varying refrigerating cycle parameters to optimize COP at different temperatures. Okay. Phase transitions, use transitions like solid, liquid, gas to gain benefits. Phase change materials in cold chain packaging to maintain temperature during transport. Thermal expansion, use temperature based dimensional changes to create movement or seals. For example of this is bimetallic strips in thermostats that bend with temperature to make break contacts. 38th principle is enriched atmosphere, use chemical reactions. So use chemical actions or replace normal environment. Example is controlled atmosphere packaging for food, low oxygen to extend shelf life. Inert environment, using inert conditions like isolate or use inert substances to prevent harm. Example from India is inert gas blanketing in fuel storage tanks to prevent explosions. Last 40th principle is composite structures. Use composite materials or combine different materials for superior properties. Example is carbon filter fiber reinforced polymer CFRP components that are used in aviation and automotive lightweighting. So that's TRIZ, guys, and it's not complete TRIZ, but we went through what TRIZ is and who invented it. What are the 40 principles of TRIZ? So that's it for today. Thanks, everyone. Have a nice day. Bye.